Imagine looking up into the sky and realizing that it has never changed. Not yesterday, not 1,000 years ago, not even 1,000,000 years ago. The same sun hangs in exactly the same place. The same shadows stretch across the ground. The same horizon glows with the same endless light. No sunrise, no sunset, no dawn breaking over distant mountains, no evening colors fading into night. Just one eternal moment, frozen beneath an alien sky. At first, it sounds impossible. After all, on Earth, everything moves. The sun rises, the sun sets. Days come and go. Seasons change. Shadows slide slowly across fields and cities. Time itself seems woven into the motion of the sky above us. But somewhere among the countless worlds orbiting distant stars, there may be planets where the sky never changes at all. And tonight, as you settle in and allow your thoughts to drift beyond the familiar boundaries of Earth, we're going to visit one of those extraordinary places. A world where time feels different. A world where morning never arrives because morning never left. A world locked forever beneath an unmoving sun. Imagine standing there now. The air is still. The landscape stretches endlessly toward the horizon. Above you hangs a star much larger than any sun you've ever seen in the sky. And no matter how long you wait, it never moves. Hours pass. Nothing changes. Days pass. Still nothing changes. Years pass. The sky remains exactly the same. How could such a world exist? The answer lies in one of the strangest phenomena discovered by astronomers studying distant exoplanets. It is called tidal locking. Many planets orbit extremely close to their stars, so close in fact that gravity begins to reshape their entire existence. Over millions of years, the star's gravity slowly acts like an invisible brake. The planet's rotation becomes slower and slower. Eventually, something remarkable happens. The planet rotates at exactly the same rate that it orbits its star. One side always faces the star. The other side always faces away, forever. Just as our moon always shows the same face to Earth, these worlds show the same face to their suns. The result is a planet divided into two eternal kingdoms. One side never experiences darkness. The other side never sees daylight. If you stood on the day side, the star would appear frozen in the sky, not because time had stopped, but because the planet itself had synchronized perfectly with its orbit. The sun would never rise. It would never set. It would simply remain there, suspended above the horizon like a celestial painting, for millions of years, perhaps even billions. The consequences of such a world would be extraordinary. On the Perpetual Dayside, temperatures could become incredibly high. The ground might bake beneath constant sunlight. Deserts could stretch for thousands of miles. Rocks might crack from endless exposure to heat. There would be no cooling night to offer relief, no sunset breeze, no twilight, only endless day. Meanwhile, on the opposite side of the planet, darkness would reign forever. Not a single sunrise would ever touch the landscape. The sky would remain permanently black. Stars would shine continuously overhead. Galaxies would drift slowly across the heavens, and temperatures could plunge to unimaginable extremes. It would be a realm of eternal night, a place where ice might accumulate for millions of years without ever melting. Yet the most fascinating region might lie between these two extremes. Astronomers call it the Terminator Zone, a narrow ring circling the planet where day and night meet. Here, the blazing heat of the dayside and the frozen darkness of the nightside could balance one another. The sun would sit forever on the horizon, never rising, never setting, just glowing endlessly in a perpetual twilight. Imagine standing there, the sky painted in shades of gold and amber, the landscape illuminated by a sunset that never ends. Mountains casting shadows that remain unchanged for centuries. Clouds drifting beneath a motionless star. If life existed on such a world, it might choose this narrow band as its home. Not too hot, not too cold, balanced delicately between fire and ice. Creatures living there would never know what a sunrise looks like. They would never watch the stars emerge at night. Children might grow up hearing stories about distant worlds where the sun moves across the sky, never believing such places could actually exist. To them, an Earth-like day would sound as strange as their endless twilight sounds to us. And perhaps that's one of the most beautiful lessons hidden among the exoplanets. The universe is under no obligation to build worlds that resemble our own. Nature is far more imaginative than we are. Some planets may have skies filled with vaporized rock. Others may wander alone through interstellar darkness. And somewhere, perhaps hundreds of light years away, there may be a quiet world where the sky has not changed for millions of years. A place where shadows never move, where sunset never ends, and where time itself seems to have fallen asleep beneath an eternal sun. Some worlds may look completely frozen from space, yet beneath miles of ancient ice, entire oceans could be quietly moving in the darkness. Imagine approaching such a planet from orbit. At first glance, it appears lifeless. Its surface is white, pale blue, and silver beneath the distant glow of its star. There are no visible seas, no rivers, no clouds drifting through the atmosphere, no signs of movement at all. It looks frozen solid, a silent sphere trapped in an endless winter. If you were passing by quickly, you might dismiss it as another dead world wandering through the galaxy. But appearances can be deceiving. Far beneath that frozen shell, hidden under miles of ancient ice, something remarkable may be happening. An ocean could be waiting. Not a small lake, not a pocket of water trapped underground. An entire global ocean. A vast sea stretching across the planet, concealed beneath a roof of ice so thick that no sunlight has touched the water for millions, perhaps billions of years. It sounds like science fiction, yet worlds similar to this may already exist. In fact, some may exist much closer than we realize. Even within our own solar system, astronomers suspect that moons such as Europa and Enceladus hide enormous oceans beneath their icy surfaces. These discoveries have changed the way we think about life, water, and the possibilities of the universe. For a long time, scientists believed that a planet needed sunlight to maintain liquid water. The logic seemed simple. Water freezes when temperatures become too low. Move far enough away from a star and everything should turn to ice. Yet nature, as it often does, had other plans. Deep inside many worlds, heat still exists. A planet may appear frozen on the outside while remaining surprisingly active within. Radioactive elements buried deep beneath the surface slowly release energy. Gravity itself can generate heat through tidal forces. The immense pressure inside a large world can trap warmth for extraordinary lengths of time. Together, these hidden sources of energy may prevent underground oceans from freezing completely. As a result, beneath an icy crust that appears lifeless from above, liquid water can continue flowing in darkness. Imagine descending through that frozen shell. The ice stretches downward for miles, perhaps tens of miles. Layer after layer of ancient frozen water surrounds you. The deeper you travel, the stranger the environment becomes. Pressure steadily increases. The ice grows denser. Crystals become compressed into forms rarely seen on Earth. Above you lies a frozen wilderness that has remained unchanged for ages. Below you, however, a different world begins to emerge. Eventually, the ice ends. And suddenly, there is water. An ocean. Dark, silent, endless. The ceiling above is made of ice. The floor may be rocky terrain hidden far below. Between them lies a vast sea untouched by sunlight. No sunrise has ever illuminated these waters. No moonlight has ever danced across their surface. No waves sparkle beneath a bright sky. Everything exists in perpetual darkness. Yet darkness does not necessarily mean lifelessness. On Earth, some of the most fascinating ecosystems exist far beneath the ocean floor around hydrothermal vents. These deep-sea environments receive no sunlight whatsoever. Instead, life survives by feeding on chemical energy released from Earth's interior. Entire communities thrive around these vents. Strange creatures flourish where conventional wisdom once predicted nothing could survive. This discovery opened a profound possibility. If life can exist in the darkness beneath Earth's oceans, could it also emerge beneath the ice-covered oceans of distant worlds? Perhaps somewhere beneath a frozen exoplanet's crust, microscopic organisms drift through black waters. Perhaps simple ecosystems have existed there for millions of years. Perhaps life does not always need sunlight. Maybe it only needs water, energy, and time. And the universe seems to have an abundance of all three. Imagine standing on the icy surface of one of these worlds. The landscape stretches endlessly in every direction. Frozen plains sparkle beneath a dim and distant sun. Towering cliffs of ice rise above the horizon. Ancient glaciers move so slowly that their motion is almost impossible to detect. Everything appears still. Everything appears silent. Yet beneath your feet, hidden beneath miles of frozen crust, an entire ocean is slowly circulating. Currents move through darkness. Warm water rises, cold water sinks. Minerals dissolve and drift. The planet is alive with motion, despite appearing frozen from above. It is a reminder that the universe often hides its most extraordinary secrets beneath calm surfaces. Some of these hidden oceans may be larger than all of Earth's oceans combined. Certain icy super-Earths could possess unimaginable quantities of water. If their internal temperatures remain warm enough, enormous liquid layers may exist beneath high-pressure ice shells. The volume of water on such worlds could dwarf anything found on Earth. Entire global oceans, thousands of miles deep, may exist beneath frozen exteriors. Trying to imagine such a place stretches the limits of human experience. Earth's deepest ocean trench reaches only a tiny fraction of those depths. These alien seas could contain environments unlike anything our planet has ever known. The pressure would be immense, the chemistry unfamiliar, the darkness absolute, and yet water would still flow. There is something strangely beautiful about these hidden worlds. They are quiet, patient, invisible. They do not announce themselves with spectacular storms or glowing atmospheres. From a distance, they appear simple, cold, frozen, ordinary. Only when we look deeper do we discover the incredible complexity hidden beneath. Perhaps that is why they capture the imagination so powerfully. They remind us that not everything important is visible. Not every ocean sparkles beneath sunlight. Not every world reveals its secrets immediately. Some stories are buried beneath layers of ice. Some mysteries wait in darkness. And some of the most fascinating places in the galaxy may be hidden beneath frozen surfaces that seem lifeless at first glance. As we continue searching the stars, these ice-covered ocean worlds remain among the most intriguing destinations we can imagine. Not because we know what lies beneath, but because we do not. Beneath those endless frozen plains, entire oceans may be quietly moving through the darkness. Currents may be flowing, chemistry may be unfolding, life may be waiting. And somewhere, beneath miles of ancient ice orbiting a distant star, a hidden sea may be dreaming in silence, untouched by sunlight, unseen by any eyes, patiently turning through the ages beneath a frozen sky. Not every planet belongs to a star. When most people imagine a planet, they picture a world circling a sun, a place warmed by daylight, guided by gravity, and connected to a larger family of worlds moving together through space. But the universe is not always so orderly. Some planets have no sunrise, no sunset, no home star glowing in their skies, no familiar system of neighboring worlds. Instead, they travel alone, far beyond the reach of any sun. These lonely wanderers drift through the vast darkness between the stars, crossing the galaxy in complete solitude. Imagine standing on such a world. There would be no bright star dominating the sky, no daylight stretching across the horizon. Above you would hang an endless canopy of distant stars, scattered across a blackness deeper than anything we experience on Earth. The darkness would not arrive at night. It would simply always be there. For centuries, rogue planets existed only as an idea. Astronomers knew that gravity could sometimes behave violently during the birth of planetary systems. Young planets often formed together within enormous disks of gas and dust surrounding newborn stars. At first, everything seems stable. Worlds slowly emerge, orbits take shape, the system begins organizing itself. But gravity has a way of creating chaos. As giant planets grow larger, their gravitational influence increases. They tug on neighboring worlds, they alter trajectories, they trigger cosmic encounters that can completely reshape a planetary system. Sometimes two giant planets pass close enough to each other that one receives a powerful gravitational slingshot. The result can be dramatic. Instead of remaining safely bound to its star, a planet may be accelerated to escape velocity. It breaks free. Its connection to the star is severed forever, and then it begins a journey unlike any other. Once ejected, the rogue planet enters interstellar space. It becomes a traveler without a destination, a world without a sunrise, a planet without a home. For billions of years, it may wander through the galaxy completely alone. The distances involved are difficult to comprehend. Even our nearest neighboring star lies over 4 light-years away. A rogue planet might spend millions of years crossing a tiny fraction of that distance. The galaxy becomes an ocean of darkness so vast that entire civilizations could rise and fall before the planet approaches another star. And yet these lonely worlds are not merely theoretical. Astronomers have found evidence that rogue planets truly exist. Some have been detected through a technique called gravitational microlensing. When a massive object passes in front of a distant star, its gravity bends and magnifies the starlight. For a brief moment, astronomers see a tiny flash, a subtle brightening, a faint signal. And hidden within that signal may be the presence of a planet traveling through the darkness alone. These detections suggest something remarkable. There may be billions of rogue planets scattered throughout the Milky Way, perhaps as many as there are stars, maybe even more. At this very moment, countless invisible worlds could be drifting through the spaces between stellar systems, silent, dark, unnoticed. Some may be enormous gas giants, larger than Jupiter. Others might be rocky planets, similar to Earth. A few could even possess moons that continue orbiting faithfully, despite the absence of a star. The idea feels strange. A moon circling a planet circling nothing, both drifting together through the darkness. Yet the universe often proves stranger than our imagination. The most surprising possibility is that some rogue planets may not be completely frozen. At first glance, that seems impossible. Without sunlight, temperatures should plummet, surface oceans would freeze solid, the landscape would become locked beneath ice. But planets possess another source of energy, their own internal heat. Deep inside many worlds, radioactive elements slowly decay. This process releases energy continuously over immense spans of time. Large planets also retain leftover heat from their formation. Even billions of years after being born, their interiors may remain surprisingly warm. If a rogue planet possesses a thick atmosphere, something extraordinary could happen. That atmosphere might trap enough heat to prevent all of the planet's water from freezing. Far beneath a frozen surface, liquid oceans could continue to exist. Hidden seas moving quietly beneath endless darkness. Imagine an ocean that has never seen sunlight, waves that have never reflected a sunrise, currents flowing through waters untouched by any day-night cycle. If life can survive around deep-sea hydrothermal vents on Earth, some scientists wonder whether similar environments could exist inside rogue planets. Perhaps somewhere in the darkness, tiny organisms drift through warm underground oceans, completely unaware that stars even exist. Such life would evolve beneath layers of ice thicker than mountains. Its entire universe would be hidden beneath a frozen shell. No sky, no sun, no moon, only darkness and water. It is one of the most fascinating possibilities in modern astronomy. Life not dependent on starlight. Life surviving in places we once thought impossible. Even without life, rogue planets remain deeply mysterious. Their surfaces may preserve ancient histories frozen in time. Unlike planets near active stars, they are largely protected from solar radiation. Geological features could remain unchanged for millions or billions of years. Craters might survive almost indefinitely. Frozen landscapes could preserve records of events from unimaginably distant ages. Some rogue planets may have once resembled Earth. Long ago, they may have orbited peaceful stars. Perhaps they possessed oceans, clouds, weather, maybe even conditions suitable for life. Then, a gravitational encounter changed everything. A giant planet passed nearby, orbits shifted, the system became unstable, and one world was cast out forever. Imagine watching your sun slowly shrink into a distant star. Year after year, it grows dimmer. The warmth fades, the skies darken. Eventually, the star becomes indistinguishable from the countless others scattered across the heavens. The planet enters permanent night, a journey with no return. Though lonely, these wandering worlds reveal something important about the universe. Planets are not merely companions to stars. They are worlds in their own right. Some remain close to their suns. Others travel paths entirely their own. The galaxy is not simply filled with stars. It may also be filled with countless hidden planets drifting silently between them. Worlds without daylight, worlds without seasons. Worlds that wander through the darkness for billions of years, while galaxies rotate around them and civilizations come and go. And perhaps that is what makes rogue planets so captivating. They remind us that not every story in the cosmos follows familiar rules. Some worlds never settle into stable homes. Some never enjoy permanent sunlight. Some spend their entire existence traveling alone through the great darkness between the stars. Yet even there, far from any sun, they remain part of the universe's endless story, still moving, still existing, still carrying their secrets through the silent ocean of space. If this quiet journey through the cosmos is helping you relax, consider subscribing and joining us for more peaceful adventures among the stars. Imagine mountain ranges not made of rock, but towering structures built from materials never naturally found on Earth. When we think of mountains, we picture familiar things. Granite peaks rising above forests, snow-covered summits touching the clouds, ancient stone shaped by wind, water, and time. Every mountain on Earth, from the towering heights of the Himalayas to the volcanic slopes of Hawaii, is built from the same ingredients that make up our planet's crust: rock, minerals, ice, dust. But beyond our solar system, nature may be working with entirely different materials. On distant exoplanets, mountains might be made from substances so strange that they challenge our understanding of geology itself. Some could be formed from exotic crystals created under immense pressure. Others might be built from frozen methane, ammonia, or carbon compounds. There may even be worlds where diamond-like structures rise toward alien skies, glittering beneath unfamiliar stars. The universe has had billions of years to experiment, and it appears to be far more creative than we once imagined. To understand how strange these mountains might be, we first need to remember that Earth represents only one possible outcome among countless planetary possibilities. Our planet formed under a specific set of conditions, a particular mixture of elements, a certain distance from the sun, a particular temperature range. But exoplanets exist in environments far different from ours. Some orbit stars much hotter than the sun. Others circle dim red dwarfs. Many form from clouds of gas and dust containing chemical ratios unlike anything found in our own planetary neighborhood. As a result, the landscapes that emerge can be astonishingly different. Imagine a planet rich in carbon, far richer than Earth. In such a world, carbon might become one of the dominant building materials of the crust. Over millions of years, heat and pressure could transform enormous quantities of carbon into crystalline forms. Entire mountain ranges might sparkle beneath the sky, not because of snow, not because of ice, but because the mountains themselves are made of crystal-like materials stretching for hundreds of miles. Sunlight reflecting from their surfaces could create dazzling displays visible from space. The peaks might shimmer like enormous gemstones scattered across the horizon. Standing before such a mountain would feel almost dreamlike. Every cliff face catching the light, every ridge glowing with countless reflections. A landscape that appears more like fantasy than reality. And yet, the physics behind it may be completely natural. Some scientists have proposed the existence of carbon-rich planets where diamond-forming conditions are far more common than on Earth. If such worlds exist, their geology may be unlike anything our eyes have ever seen. But crystal mountains may not require diamonds. Under extreme conditions, many materials can form unusual crystalline structures. Deep inside planets, pressure reaches unimaginable levels. Atoms are squeezed together. New arrangements emerge. Minerals behave differently. The result may be entire classes of materials that barely exist on Earth. On some worlds, crystals could grow slowly over millions of years, forming gigantic structures larger than any mountain range we know. Imagine a landscape where enormous crystalline formations emerge from the ground like frozen waves, their surfaces smooth and reflective, their edges sharp as glass. The sunlight of an alien star passing through them and scattering into colors unknown to human eyes. The view would be breathtaking and perhaps a little unsettling, because these mountains would not look alive in the way Earth's mountains do. They would seem almost artificial, too perfect, too geometric, too precise, like natural structures that somehow resemble architecture. Yet nature often creates remarkable symmetry when given enough time. Even here on Earth, snowflakes, quartz crystals, and basalt columns reveal patterns that seem designed. Now imagine those same processes operating on a planetary scale. Entire mountain ranges built from geometry itself. Some planets may host mountains made from frozen substances that rarely remain solid on Earth. In the outer reaches of planetary systems, temperatures can fall to extraordinary lows, cold enough for methane to freeze, cold enough for ammonia to become solid, cold enough for exotic chemical compounds to form landscapes unlike anything we know. On such worlds, mountains may not be made of stone at all. They could be made of frozen hydrocarbons, frozen gases, layers of chemical ice stacked mile upon mile across the surface. To an explorer, these mountains might appear strangely colorful. Soft blues, pale oranges, subtle pinks. Colors created by chemistry rather than vegetation or rock. Their slopes might sparkle beneath faint starlight, their peaks rising silently into skies darker than any found on Earth. Unlike our mountains, they might slowly change shape over time. Certain materials could sublimate directly into gas. Entire cliffs may gradually disappear. Valleys could form not from flowing water, but from the slow evaporation of frozen chemicals. The landscape would seem almost alive, constantly shifting, constantly transforming. Some of the strangest possibilities may exist beneath thick atmospheres where the surface itself is hidden from view. Imagine a giant planet with crushing pressure deep below its clouds. Far beneath the atmosphere, materials could be compressed into forms that cannot naturally survive on Earth. Immense crystal layers might develop over geological timescales, structures rising thousands of feet high, mountains buried beneath oceans of exotic liquids, no sunlight ever reaching them, no eyes ever seeing them. Silent peaks hidden forever beneath layers of pressure and darkness. These mountains may exist completely unknown to the universe, standing for billions of years without witnesses. A reminder that beauty does not require observation. The cosmos creates wonders whether anyone sees them or not. One particularly fascinating possibility involves high-pressure ice. On Earth, ice feels fragile, temporary, something that melts easily. But under extreme pressure, water can transform into exotic forms of ice, far denser and stronger than ordinary frozen water. Scientists have identified several versions of these high-pressure ice phases. Some may exist deep inside large icy worlds. There, mountains of solid ice could behave more like rock than anything we would recognize as frozen water. Entire continents might be supported by these exotic structures, towering peaks made from compressed crystalline ice stronger than granite. The word ice hardly seems adequate to describe such a material. It would be something entirely different, something born from pressure, darkness, and immense spans of time. And perhaps the most wonderful aspect of these strange mountains is that they remind us how limited our experience truly is. For thousands of years, humanity knew only one world, one type of mountain, one kind of landscape. Now we know the galaxy contains hundreds of billions of planets, each with its own chemistry, its own history, its own possibilities. Somewhere out there, mountain ranges may rise beneath purple skies. Crystal peaks may catch the light of twin suns. Frozen methane cliffs may overlook oceans hidden beneath ice. Diamond-like formations may stretch beyond distant horizons. We may never walk among them. We may never touch their surfaces. But knowing they could exist expands our sense of wonder. The universe becomes larger, richer, more imaginative. And as we continue discovering new worlds, we are reminded that nature is under no obligation to repeat itself. Every planet is a new experiment. Every landscape a new story. Every mountain a different answer to the question of what a world can become. So tonight, as you drift through the quiet reaches of the cosmos, imagine those distant peaks. Silent crystal mountains standing beneath unfamiliar stars, frozen towers rising from alien planes, ancient structures shaped by physics, chemistry, and time, waiting in the darkness, patiently keeping their secrets. And somewhere far beyond the edge of our imagination, those strange mountains may already exist, shining softly beneath skies no human has ever seen. What happens when a star dies? Most of us imagine an ending, a final explosion, a fading ember, a brilliant light disappearing forever into the darkness. Stars seem permanent when viewed from the perspective of a human life. They shine night after night, year after year, unchanged and eternal. Yet every star has a lifespan. Every sun that burns today will eventually reach its final chapter. For many worlds, the death of a star is a catastrophe beyond imagination. Oceans evaporate, atmospheres vanish, planets are scorched, shattered, or swallowed. Entire planetary systems can be transformed beyond recognition. But the universe rarely tells simple stories, because sometimes after a star dies, something unexpected happens. New worlds may be born. It sounds impossible at first. How can creation follow destruction? How can planets emerge from the remains of a dying sun? Yet astronomy has revealed that the cosmos often builds new beginnings from the ashes of old endings. To understand this strange possibility, imagine a star much like our own sun. For billions of years, it shines steadily. Hydrogen fuses into helium deep within its core. The star radiates warmth and light across its planetary family. Worlds orbit peacefully. Seasons come and go. Everything appears stable. But eventually, the hydrogen fuel begins to run out. Slowly, the balance changes. The star starts to evolve. Its outer layers expand. Its brightness increases. What was once a calm yellow sun transforms into a swollen red giant. The star grows larger and larger. Any nearby planets may face terrible consequences. Some could be engulfed entirely. Others might experience temperatures so extreme that their surfaces melt. Oceans boil away. Atmospheres are stripped into space. The familiar architecture of the planetary system begins to unravel. For a time, it seems as though destruction has won. But then something remarkable occurs. The dying star sheds its outer layers. Huge shells of gas drift outward into space. Glowing clouds expand across the darkness. The star's former atmosphere becomes a vast nebula surrounding the shrinking stellar core. At the center remains a white dwarf, a dense stellar ember roughly the size of Earth, but containing nearly the mass of the original star. The violence is over. Silence returns. Yet the story is not finished. The gas and dust expelled during the star's death do not simply disappear. They continue drifting through space. Gravity begins its quiet work once again. Tiny particles collide. Clumps form. Material gathers. Over immense periods of time, new structures may emerge from the debris. Just as planets once formed around newborn stars, some scientists believe that second-generation worlds may form around dying stars as well. Planets born not from creation, but from destruction. Imagine standing on such a world. Everything around you would owe its existence to a dead star. The ground beneath your feet, the mountains on the horizon, the minerals within the crust. Even the atoms making up the atmosphere, all assembled from material expelled during a stellar death long ago. You would live on a planet whose entire history began after the star itself had already reached the end of its life. In a sense, these worlds would be cosmic rebirths, the universe recycling its own history. The idea may sound unusual, but nature has already shown us many examples of renewal. Stars are born from the remnants of older stars. Heavy elements like carbon, oxygen, iron, and calcium are forged inside stellar interiors and scattered into space when stars die. The atoms within our own bodies were once part of ancient stars that no longer exist. Death and creation are deeply connected throughout the cosmos. Perhaps planets follow the same pattern. Some of the most fascinating discoveries involve planets orbiting white dwarfs. These stellar remnants should, at first glance, seem like unlikely places for planetary systems. After all, the original star has already gone through a violent transformation. Many of its planets may have been destroyed. Yet astronomers continue finding evidence that planets can survive, migrate, or even form around these stellar ghosts. Imagine a white dwarf hanging in the sky. It would appear very different from our sun. Smaller, dimmer, yet incredibly dense. A teaspoon of white dwarf material would weigh tons on Earth. Around such a strange object, planets might circle quietly for billions of years, their skies illuminated not by a blazing sun, but by the fading glow of a stellar ember. The daylight would feel different, softer, more distant, a reminder that the star above has already lived an entire lifetime. Some planetary systems may become even stranger. When massive stars die in supernova explosions, they leave behind neutron stars. These objects are among the most extreme things in the universe. They are incredibly dense, rapidly spinning, often surrounded by powerful magnetic fields. No one originally expected planets to exist near such violent remnants. Yet the first confirmed exoplanets ever discovered were found orbiting a pulsar, a rapidly rotating neutron star. This discovery stunned astronomers. How could planets survive such an explosion? One possibility is that they formed afterward. The supernova expelled enormous quantities of material into space. Some of that material may have settled into a disk around the neutron star. Over time, gravity gathered the debris together. New planets emerged, worlds born from the wreckage of a stellar catastrophe. Imagine living beneath a sky dominated by a pulsar. Instead of a steady sun, the heavens would flash rhythmically as beams of radiation swept across space. The parent star would no longer resemble a star at all. Yet planets could still exist there, silent witnesses to one of the most dramatic transformations in nature. These worlds remind us that the universe is far more resilient than we often assume. Even after tremendous destruction, gravity remains patient, matter remains available, time continues moving forward. Given enough of it, entirely new worlds may emerge. There is something strangely comforting about that idea. The cosmos does not view endings the way we do. To us, an ending feels final, permanent, absolute. But the universe seems to operate differently. The death of one object often creates opportunities for something new. A star dies, its materials scatter, new stars form, new planets emerge. New possibilities appear. The cycle continues. Perhaps somewhere in the galaxy tonight, a white dwarf is surrounded by a ring of dust, slowly gathering into future worlds. Perhaps tiny grains are already colliding, already sticking together, already beginning a process that will eventually create mountains, valleys, oceans, and skies. The first chapter of a planet that does not yet exist. And perhaps billions of years from now, if anyone were standing there, they would look upward and see the faded remnant of the star that gave them life. Not a blazing sun, not a newborn star, but a quiet stellar ghost. A reminder that their world was born from ashes, that destruction became creation, that endings became beginnings, and that throughout the universe, even death is sometimes just another way for new worlds to be born. On some planets, a single day might last longer than an entire human lifetime, turning sunrise into a centuries-long event. Imagine waking up one morning and watching the sun rise above the horizon. The light slowly spreads across the landscape. Shadows begin to retreat. The sky changes color. Everything seems normal. But then something strange happens. The next day, the sun has barely moved. A year passes. Still, it remains close to the horizon. 10 years later, the sunrise continues. Entire generations could live and die while the morning sky slowly brightens. On Earth, we rarely think about the length of a day. The planet rotates once every 24 hours, creating the familiar rhythm of sunrise and sunset that has guided life for billions of years. Every living thing on Earth has evolved beneath this cycle. Plants open and close with the changing light. Animals sleep and wake according to the passing of day and night. Even our own bodies carry internal clocks synchronized to Earth's steady rotation. But the universe is under no obligation to follow Earth's schedule. Beyond our solar system, there may be worlds where time itself feels completely different. Some planets rotate so slowly that a single day lasts months. Others may require years. A few could take centuries to complete a single rotation. On such worlds, sunrise becomes something entirely unfamiliar. Not a brief event lasting minutes, not even a process measured in hours. Instead, it becomes an era, a gradual transformation of the sky unfolding across lifetimes. The reasons for these incredibly slow rotations vary. Sometimes the cause is gravity. When a planet orbits very close to its star, tidal forces can slowly alter its rotation over millions of years. The same process has already affected our moon. The moon rotates at exactly the same rate that it orbits Earth. As a result, we always see the same side facing us. Astronomers call this tidal locking. Many exoplanets orbit extremely close to their stars. In these systems, tidal locking may be common. Some planets eventually stop rotating relative to their stars altogether. One side permanently faces the sunlight, the other remains trapped in endless darkness. For these worlds, sunrise never comes at all. But there may also be planets caught somewhere in between. Worlds rotating so slowly that daylight crawls across the surface at an almost unimaginable pace. Imagine standing on such a planet. At first, the horizon appears dark. The stars shine brightly overhead. The landscape rests beneath a deep twilight. Then, slowly, over years and decades, a faint glow begins to emerge. Not enough to call it dawn, just a subtle brightening, a slight change in the darkness. The stars nearest the horizon begin to fade. The sky turns from black to deep violet. The process continues year after year. Children born during the first signs of dawn might become adults before the sun fully clears the horizon. Entire civilizations could develop traditions centered around the slow progression of light. History itself might be measured by stages of sunrise. Imagine ancient records describing the moment the first golden light touched a distant mountain range. Imagine descendants, centuries later, celebrating the arrival of the full morning sky. The pace of life would be fundamentally different. Time would feel stretched. Patience would become a necessity. Nature would adapt accordingly. If life existed on such a world, its rhythms would bear little resemblance to those on Earth. Plants might spend decades preparing for daylight. They could store energy for generations, slowly responding to the changing brightness. Animals might enter long periods of dormancy. Entire ecosystems could evolve around cycles so long that they seem almost geological rather than biological. Even the weather would behave differently. On Earth, sunlight moves across the planet quickly. Temperatures rise and fall each day, but on a slow-rotating world, heating occurs gradually. One region may spend decades warming beneath an advancing sunrise. Air currents would shift slowly. Cloud patterns might persist for years. Massive weather systems could remain stable for astonishing lengths of time. A storm might outlive the people who first observed it. The sky itself could become a living archive of slow-moving atmospheric change. Some exoplanets may experience particularly dramatic transitions between day and night. As sunlight finally reaches regions that have been frozen for decades or centuries, enormous environmental transformations could occur. Ice fields may begin melting. Frozen gases could evaporate into the atmosphere. Ancient rivers might briefly flow once again. The arrival of sunlight could awaken entire landscapes from prolonged dormancy. Imagine watching a frozen world gradually come alive. Not over days, not over seasons, but across generations. Each year bringing tiny changes, each decade revealing another stage of the transformation. The planet itself would seem to breathe at a pace almost too slow to perceive. There are places in our own solar system that offer hints of these unusual rhythms. Mercury, the innermost planet, rotates very slowly compared to Earth. A single solar day on Mercury lasts approximately 176 Earth days. If you stood on its surface, the sun would move across the sky with extraordinary slowness. Yet even Mercury is only a modest example compared to what may exist elsewhere in the galaxy. Some exoplanets likely experience much longer cycles. Others may possess complex rotational patterns caused by interactions with neighboring planets or multiple stars. The possibilities are nearly endless. One particularly fascinating idea involves planets orbiting red dwarf stars. These small stars are among the most common in the Milky Way. Many of their planets orbit extremely close to receive enough warmth for liquid water. Because of that proximity, tidal locking becomes highly likely. But not every planet settles into a perfectly synchronized state. Some may become trapped in unusual rotational resonances. Their days might stretch for months or years. Sunrise could arrive incredibly slowly, painting the landscape with changing light that advances almost imperceptibly. The experience would feel less like a daily event and more like the turning of an age. There is something peaceful about imagining such worlds. On Earth, life often feels rushed. Days disappear quickly, weeks become months, years pass before we fully notice them. Everything moves fast. But on these distant planets, nature follows a different tempo. The sky does not hurry. The sun does not race across the heavens. Light unfolds gradually, patiently, as though the universe itself has slowed down. Perhaps standing there would change the way we think about time. Perhaps we would stop measuring moments so carefully. Perhaps we would learn to appreciate slower rhythms. After all, the cosmos is full of processes that unfold across millions and billions of years. Stars are born slowly. Galaxies evolve slowly. Planets themselves take immense spans of time to form. Maybe these worlds with century-long sunrises simply reveal the natural pace of the universe more honestly than Earth does. And somewhere tonight, beneath a distant alien sky, there may be a horizon glowing softly with the earliest signs of dawn. A sunrise that began long before our grandparents were born. A sunrise that will continue long after we are gone. A slow and beautiful transition from darkness into light. A reminder that the universe keeps time in many different ways. And on some worlds, morning itself can last a lifetime. Across the galaxy, entire planetary systems move like celestial music, each world following a rhythm that has remained unchanged for eons. If you could somehow listen to gravity itself, you might discover that the universe is not silent at all. Far beyond our solar system, there are planetary systems where worlds move together in patterns so precise that astronomers compare them to music. Invisible harmonies guide their motion. Each planet follows its own path around its star, yet somehow every orbit remains connected to the others. These systems are not random collections of worlds. They are cosmic dances. Imagine standing on a distant planet and looking toward the sky. Above you, neighboring worlds glide across the darkness according to schedules older than human civilization. They rise and set with perfect predictability. Every movement has been rehearsed by gravity for millions, sometimes billions of years. One planet circles its star twice, while another completes 3 orbits. A third planet completes 4. A fourth completes 6. Together they create an intricate gravitational rhythm, a repeating pattern that rarely changes. Astronomers call these arrangements orbital resonances, but the scientific term hardly captures their beauty. They are among the most elegant structures ever discovered in nature. Our own solar system contains hints of this harmony. Several of Jupiter's largest moons participate in a resonance known as the Laplace resonance. As Io circles Jupiter 4 times, Europa circles twice, and Ganymede circles once. This pattern has persisted for unimaginable stretches of time. Every orbit influences the next. Every movement sends tiny gravitational signals through the system. Like musicians in an orchestra following the same conductor, each moon contributes to a greater whole. Now imagine similar harmonies involving entire planets. The famous TRAPPIST-1 system offers one of the most remarkable examples ever found. 7 rocky worlds orbit a small red star. Many of them are linked together in an elaborate chain of resonances, each planet gently tugging on its neighbors with every orbit. If one world drifts slightly, gravity nudges it back toward the rhythm. The system behaves almost like a giant clock, its gears made not of metal, but of worlds. And this clock has been ticking for billions of years. The existence of these resonant systems tells us something profound about how planets form. Long ago, these worlds were likely born within vast disks of gas and dust surrounding young stars. As they grew, they migrated through the disk, slowly moving inward or outward. Along the way, gravity captured them into synchronized patterns. Like dancers gradually finding the same beat, the planets settled into stable relationships. Once established, those relationships could endure for extraordinary lengths of time. Some may survive longer than entire mountain ranges on Earth, longer than oceans, longer than civilizations, perhaps longer than humanity itself. On certain worlds within these resonant systems, the sky would reveal evidence of this harmony. Neighboring planets might appear unusually bright. Some could grow larger and smaller in the sky according to perfectly repeating cycles. Observers living there could potentially predict celestial events centuries in advance. The universe would seem ordered and reliable, a cosmic calendar written in motion. Yet these harmonies are not rigid. They are delicate. Every gravitational interaction matters. Every planet influences every other. The balance remains stable only because countless forces work together continuously. It is a reminder that stability is often not the absence of motion. Instead, stability can emerge from motion itself. A spinning bicycle remains upright because it moves. A planetary system remains stable because its worlds keep dancing. The concept becomes even more fascinating when we consider what these harmonies might mean for life. Stable planetary systems provide stable environments. Temperatures remain predictable, orbits remain consistent. Catastrophic disruptions become less likely. Life, if it exists, benefits from reliability. Evolution has time to work. Complex ecosystems can develop over immense periods. A planet trapped within a long-lasting resonance may enjoy billions of years of relative calm. The universe, at least locally, becomes a dependable place, and time becomes an ally. Some researchers even wonder whether intelligent civilizations elsewhere might have used these celestial rhythms as natural clocks. Just as ancient humans tracked the movements of the moon and stars, distant civilizations could observe neighboring planets moving through resonant cycles. The sky itself would become a giant astronomical instrument, a source of knowledge, a source of wonder, perhaps even a source of mythology. Imagine a civilization whose entire calendar depends on the appearance of a neighboring world every few hundred days. Imagine festivals celebrated when multiple planets align, stories passed down through generations about the great dance overhead, the rhythms of the heavens becoming part of culture itself. And yet, despite their beauty, resonant systems remain fragile in their own way. A passing star, a giant migrating planet, an unexpected gravitational disturbance. Any of these events could eventually disrupt the harmony. The dance would continue, but the choreography might change. New rhythms would emerge, old patterns would fade. Nothing in the universe lasts forever, not even perfection. Still, many of these systems have endured for billions of years. That endurance alone is astonishing. While continents drift, while stars age, while galaxies slowly evolve, these planetary dances continue, orbit after orbit, year after year, silent and precise. The planets never grow tired. Gravity never misses a beat. Somewhere tonight, far beyond anything visible in Earth's sky, entire systems of worlds continue their ancient choreography. Planets circle red dwarfs. Mini Neptunes glide past rocky neighbors. Hidden oceans orbit distant suns, all moving according to rhythms established before complex life ever appeared on Earth. And perhaps that is one of the most comforting thoughts in astronomy. The universe is often portrayed as chaotic and violent. Stars explode, black holes collide, galaxies merge. Yet amid all that drama, there are also places of extraordinary order. Places where gravity has spent billions of years composing something beautiful. Places where entire solar systems move together with the grace of a perfectly performed symphony. As you relax and drift deeper into the quiet of this journey, imagine one of those distant worlds. Imagine standing beneath an alien sky. Above you, neighboring planets trace their familiar paths, exactly where they were yesterday, exactly where they will be tomorrow, exactly where they may remain for millions of years to come. A cosmic rhythm without hurry, a celestial song without end. And somewhere among those countless stars, the dance continues. What if the sky above you wasn't blue? Somewhere out there, alien sunsets may glow emerald green, deep violet, or shimmering silver. For most of human history, we have taken the color of the sky for granted. Every morning, sunlight filters through Earth's atmosphere, scattering blue wavelengths across the heavens. It is such a familiar sight that we rarely stop to wonder whether the sky could look any different. But the moment we leave Earth in our imagination, everything changes. The universe contains billions of planets, each with its own atmosphere, its own chemistry, its own relationship with its star. And on many of those worlds, the sky may be painted in colors no human has ever seen. Imagine standing on a distant planet, orbiting a small red dwarf star. The sunlight would already be different. Instead of the bright golden light we know, the star would cast a softer crimson glow across the landscape. The atmosphere would interact with that light in unique ways, scattering different wavelengths than Earth's atmosphere does. The result might be a sky that appears pink during the day, or copper-colored, or deep orange, stretching endlessly from horizon to horizon. Sunsets there could be even stranger. As the star slowly sinks below the landscape, the sky might transition through shades of purple and crimson, unlike anything found on Earth. The colors could linger for hours, the air itself becoming a giant canvas painted by light. On another world, orbiting a hotter and brighter star, the daytime sky might appear pale white. The intense starlight could overwhelm familiar colors, creating an atmosphere that glows almost silver. Clouds would drift across a metallic sky, reflecting sunlight like polished glass. Morning would not arrive in blue. It would arrive in silver, and evening might fade into shimmering shades of gold. The beauty of alien skies comes from a simple truth. Color is not fixed. Color is created. It emerges from the interaction between light and matter. Change the star and you change the light. Change the atmosphere and you change the colors. Change both and entirely new skies become possible. Some planets may possess atmospheres rich in methane. Here on Earth, methane exists only in small quantities, but on distant worlds it may dominate the atmosphere. Methane absorbs red wavelengths of light, while allowing blue wavelengths to pass through more easily. This effect can create unusual visual experiences. A sunset on such a world might glow turquoise instead of red. The sky overhead could deepen into shades of blue-green. The familiar colors of dawn and dusk would be completely reversed. Visitors from Earth might find it beautiful, or perhaps strangely unsettling. After all, our brains evolved beneath blue skies and orange sunsets. Alien colors would challenge every instinct we possess. Farther out in the galaxy, there may be frozen worlds wrapped in dense layers of nitrogen, methane, and exotic gases. Their skies might appear dim and muted. Sunlight arriving from distant stars would be weak and faint. The atmosphere could scatter the remaining light into soft lavender hues. Imagine walking across an icy plain beneath a violet sky. No birds, no trees, no sounds except the whisper of distant winds. Above you, pale purple clouds drift through the cold. The landscape glows faintly beneath a star that barely warms the surface. It would feel like standing inside a dream. Some worlds may possess skies that are permanently hazy. Tiny particles suspended high in the atmosphere could scatter sunlight in unusual ways. Volcanic activity, mineral dust, organic compounds. Each ingredient contributes its own signature to the sky. On one planet, the atmosphere might create a permanent golden haze, the entire world bathed in warm amber light. On another, thick clouds of hydrocarbon particles could produce skies tinted deep orange or rust red. Even midday would resemble an endless sunset. And then there are the truly exotic possibilities. Some exoplanets orbit stars that emit large amounts of ultraviolet light. If their atmospheres interact with that radiation in the right way, entirely unfamiliar color combinations could emerge. Researchers have suggested that some alien skies might appear green, not because the atmosphere itself is green, but because of how starlight is filtered and scattered before reaching the surface. Imagine looking upward and seeing a vast emerald dome stretching across the horizon, clouds drifting through shades of jade and seafoam, a green sunrise illuminating distant mountains. To us, it would seem impossible, yet physics allows it. Nature often proves more imaginative than our expectations. Weather would make these skies even more dynamic. Clouds on Earth are mostly composed of water droplets or ice crystals, but on exoplanets, clouds may form from entirely different substances. Silicates, sulfur compounds, ammonia, even vaporized metals. These exotic clouds could reflect light in unusual ways, creating shimmering displays across the heavens. An afternoon storm might transform the sky into layers of silver and violet. A passing cloud deck could scatter sunlight into brilliant halos, the atmosphere itself becoming a constantly changing work of art. Some giant planets may never experience blue skies at all. Their atmospheres are so deep and dense that sunlight struggles to penetrate far below the cloud tops. Observers floating within these immense gaseous worlds might witness skies of endless gold, crimson, or bronze. Cloud layers stretching thousands of miles, storm systems larger than entire planets, light filtering through thick atmospheric layers like sunlight through stained glass. every glance upward revealing a masterpiece of color and motion. Perhaps the most beautiful skies of all belong to tidally locked worlds. These planets always show the same face to their stars. One side remains locked in eternal daylight, the other rests in perpetual night. Between them lies a twilight zone where day and darkness meet. Imagine standing there. Ahead, a brilliant sun frozen forever above the horizon. Behind you, endless stars shining through permanent night. And above, a sky painted in gradients impossible to find on Earth. Orange fading into violet, gold merging with black. A horizon where two worlds meet, one of light, one of darkness. The colors would never change. The sky would remain suspended in a single eternal sunset. And perhaps somewhere among those countless alien skies, life has evolved beneath colors very different from our own. Creatures there may consider green skies ordinary, silver dawns familiar, purple afternoons completely normal. Their artists paint landscapes we cannot imagine. Their stories describe sunsets unlike anything in human experience. To them, Earth's blue sky might seem just as exotic as theirs seem to us. That thought carries a quiet kind of wonder. We often assume our world is the standard, the reference point, the normal version of reality. But the universe suggests otherwise. Earth is not the template. It is simply one variation among countless possibilities, one sky among billions, one palette in an endless cosmic gallery. And tonight, as darkness settles above our own familiar world, it is comforting to remember that somewhere far beyond the reach of our eyes, other skies are glowing. Green skies, silver skies, violet skies, skies illuminated by red suns, white suns, and stars unlike any we have ever known. Worlds where sunsets unfold in colors no human has witnessed. Worlds where dawn arrives painted in shades without names. And while we may never stand beneath those alien heavens, we can still imagine them. We can wonder about them. And perhaps, as we drift peacefully through the quiet of the night, we can picture those distant skies glowing softly across the galaxy, silent, beautiful, and waiting to be discovered. Some planets may have weather systems so large and persistent that a single storm could survive longer than human civilization. On Earth, storms come and go. A thunderstorm may last a few hours. A hurricane may survive for several days or weeks before eventually weakening and disappearing. Even the largest weather systems on our world are temporary visitors, fleeting patterns in an atmosphere that is constantly changing. But elsewhere in the universe, storms may operate on entirely different scales. Some could endure not for days, not for years, but for centuries, perhaps even millennia. Imagine standing on a distant world where the same storm has been raging since before the first pyramids were built on Earth. A storm older than recorded history. A storm that has watched civilizations rise and fall while continuing its endless rotation across an alien sky. It sounds impossible. Yet even within our own solar system, we already know something similar exists. Jupiter's Great Red Spot is one of the most famous storms ever discovered. This enormous vortex is so large that multiple Earths could fit inside it. Astronomers have observed it for centuries, and evidence suggests it may have existed for much longer. Generation after generation of humans have looked through telescopes and seen the same giant storm swirling through Jupiter's atmosphere. Now imagine what might exist on planets beyond our solar system. Many exoplanets are far larger than Jupiter. Some possess atmospheres thousands of miles deep. Others orbit close to their stars, absorbing tremendous amounts of heat that continuously fuel atmospheric motion. These conditions can create weather systems unlike anything Earth has ever experienced. On certain giant planets, winds may race around the globe at thousands of miles per hour. Heat from the star pours into one side of the planet, while the opposite side remains cooler. The resulting temperature differences drive enormous atmospheric currents. Entire hemispheres become engines of motion. Storms form, they merge, they grow, and in some cases, they may never truly end. Picture a world wrapped entirely in clouds. No visible surface, no continents, no oceans. Only endless layers of atmosphere extending downward into darkness. Within those cloud layers, storms the size of planets may circle endlessly. Towering cloud formations rise higher than Earth's atmosphere. Lightning flashes continuously through curtains of vapor. Thunder, if it could be heard, might roll for hundreds of miles. The sky would never be calm. It would never become still. Weather itself would define the world. Some exoplanets are tidally locked to their stars. One side permanently faces daylight, the other remains trapped in eternal night. Between them lies a narrow region of twilight. These worlds may generate some of the most extreme weather in the galaxy. The day side becomes intensely hot. The night side remains cold. Air constantly rushes between the two hemispheres in an attempt to balance the temperatures. The result can be global wind systems of astonishing power. Imagine standing beneath a sky where winds never stop, where every hour resembles the center of a hurricane, where clouds race overhead faster than commercial aircraft, where entire weather systems wrap around the planet like gigantic rivers in the sky. And yet, despite their violence, these storms might be remarkably stable. Not chaotic, not random, but persistent, like giant atmospheric machines operating continuously for millions of years. Some worlds may experience rain unlike anything found on Earth. On hot gas giants, temperatures become so extreme that materials we consider solid can exist as vapor. Iron, silicates, minerals, even metals. High above the clouds, these substances may condense into droplets. Then gravity takes over. Rain begins to fall. Not water, not ice, but molten metal. Imagine clouds of vaporized iron drifting through a crimson sky, tiny droplets forming within them, then falling toward the lower atmosphere as metallic rain. Far below, intense heat vaporizes them again. The cycle repeats endlessly. An alien weather pattern forged from elements normally found inside mountains. Other planets may experience storms composed of dust, not ordinary dust. Entire atmospheric systems built from microscopic particles of rock. Powerful winds lift these particles high into the sky. Once airborne, they remain suspended for months, years, perhaps decades. The atmosphere becomes thick with haze. Sunlight struggles to penetrate. The sky turns copper-colored. The horizon fades into obscurity. On such worlds, storms may slowly migrate around the planet, reshaping the climate wherever they pass. Some scientists suspect that certain exoplanets may host storms far more energetic than anything we know. Lightning generated within their cloud layers could dwarf Earth's most powerful electrical discharges. A single bolt might release astonishing amounts of energy. Entire regions of the atmosphere could glow with electrical activity. Night skies illuminated by continuous flashes, clouds flickering with silent light, the heavens transformed into a giant electrical ocean. And then there are the frozen worlds. At first glance, they might seem peaceful, still, silent. But beneath their tranquil appearance, weather may remain surprisingly active. Powerful winds sweep across icy plains. Snow made of methane, ammonia, or nitrogen drifts through the atmosphere. Gigantic storm systems move slowly across frozen landscapes. Months pass, years pass. The storms continue. Even cold worlds possess weather. Even darkness has motion. What makes these storms especially fascinating is their scale. On Earth, weather feels large because we experience it personally. A thunderstorm can cover an entire city. A hurricane can span hundreds of miles. Yet compared to some exoplanet storms, Earth's weather is tiny. A storm on a giant exoplanet could cover half the globe, its cloud systems stretching across millions of square miles, its winds influencing entire hemispheres, its lifetime measured not in days, but in centuries. To observers living there, if life were possible, the storm would simply be part of the environment, like a mountain, like an ocean, something permanent, something that has always existed. Perhaps that is the strangest aspect of alien weather. It forces us to rethink our understanding of time. We often view storms as temporary events, brief interruptions in otherwise stable conditions. But elsewhere in the universe, storms may be the stable condition. They may define the climate, define the landscape, define the very identity of a planet. A world could spend most of its existence beneath swirling clouds, its weather becoming its most recognizable feature, its atmosphere telling a story written over millions of years. And as we continue discovering new exoplanets, we keep finding evidence that the universe is more creative than we imagined. Every distant world seems to offer a new variation on familiar ideas. Different skies, different clouds, different winds, different storms, yet all governed by the same fundamental laws of physics: gravity, temperature, pressure, motion. The ingredients remain familiar. The results become extraordinary. Tonight, somewhere in the galaxy, enormous storms are still turning. Clouds larger than continents continue their endless rotation. Lightning flashes through alien atmospheres. Winds race around distant worlds we may never visit. Some of those storms began long before human history. Some may continue long after our own civilization has become part of the distant past. And perhaps there is something strangely comforting about that thought. The universe is always moving, always changing. Yet in its own way, it is also remarkably patient. Storms spin, planets turn, stars shine. The cosmic weather continues its ancient work. Silent from our perspective, invisible to our eyes, but endlessly alive beneath distant skies. As you settle deeper into the quiet of the night, imagine those faraway worlds wrapped in their eternal storms. Clouds circling beneath unfamiliar stars. Lightning flickering across horizons no human has ever seen. Great atmospheric engines turning slowly through the darkness. Ancient, powerful, beautiful, and still spinning tonight. Before Earth existed, before the sun was born, some planets were already circling their stars in the darkness of the young universe. Tonight, we travel farther back in time than almost any journey we've taken before, not just across space, but across billions of years of cosmic history. Imagine looking up at a night sky that existed long before our world formed, long before the first oceans appeared on Earth, long before dinosaurs, forests, mountains, or even the sun itself. Somewhere in that ancient darkness, planets were already there, silent, patient, orbiting their stars while the universe was still young. These worlds are among the oldest planets we have ever discovered, survivors from an era so distant that it almost feels impossible to comprehend. And yet, they are real. As you settle in and allow your thoughts to drift, imagine a planet that has witnessed nearly the entire history of the Milky Way, a world that has completed billions upon billions of journeys around its star. While galaxies collided, stars were born, and entire civilizations on Earth rose and disappeared without leaving a trace. The universe is old, very old. Current estimates place its age at roughly 13.8 billion years. Earth, by comparison, formed about 4.5 billion years ago. That means our planet has existed for only about 1/3 of cosmic history. For most of the universe's lifetime, Earth simply did not exist. But some planets may have. Astronomers have discovered planetary systems that appear to be far older than our own solar system. Some are estimated to be 8, 10, or even more than 11 billion years old. When these worlds first formed, the universe itself was a very different place. The Milky Way was younger. The spiral arms had not yet taken their modern shape. Many of the stars we see in the sky tonight had not been born. The heavy elements necessary for building planets were far rarer than they are today. This creates an interesting mystery. Early in cosmic history, there were fewer ingredients available for constructing rocky worlds. The first generations of stars were composed mostly of hydrogen and helium. Only through countless stellar lifetimes were heavier elements gradually created and scattered through space. Iron, silicon, carbon, oxygen. The materials that make up planets and ourselves had to be forged inside stars before they could become part of new worlds. For a long time, scientists wondered whether ancient stars would even possess enough heavy elements to form planets at all. Yet nature once again proved more creative than expected. Planet formation appears to have begun surprisingly early. Even when the galaxy was young and resources were limited, gravity found a way. Dust gathered. Particles collided. Disks formed around newborn stars, and slowly, quietly, planets emerged. Some of those planets may still exist today. Imagine standing on one of these ancient worlds. The landscape around you might look ordinary at first glance. Mountains, valleys, rocky plains. perhaps frozen oceans, perhaps deserts stretching beneath distant stars. But everything around you would possess a history almost beyond imagination. Every stone beneath your feet might have existed before the sun was born. Every mountain could have survived billions of years of cosmic change. Every sunrise would illuminate a world older than Earth itself. It is difficult for the human mind to grasp such timescales. 100 years feels long to us. 1,000 years seems ancient. Even recorded human history spans only a few thousand years. But these planets have existed for billions upon billions of years. Entire geological eras on Earth would pass like brief moments compared to their lifetimes. While continents drifted across Earth's surface, these worlds continued orbiting. While dinosaurs ruled our planet, they continued orbiting. While humanity evolved, built cities, crossed oceans, and launched telescopes into space, they continued orbiting. Steady, unchanging, patient. One remarkable example is the planetary system around the ancient star known as Kepler 444. This system is estimated to be more than 11 billion years old. Its 5 rocky planets formed when the universe was less than 3 billion years old. That means these worlds have existed for most of cosmic history. If any of them possess stable surfaces, they have experienced nearly unimaginable stretches of time. And that leads to an intriguing thought. If life can arise on suitable planets, then ancient worlds may have had far more time for life to develop than Earth has enjoyed. Life appeared on Earth relatively quickly after our planet cooled. Over billions of years, simple organisms gradually evolved into increasingly complex forms. Eventually, intelligent beings emerged who could ask questions about the universe itself. Now imagine a planet that had a head start of several billion years. What might happen there? Would life remain microbial? Would complex ecosystems emerge? Could intelligence arise? Would civilizations develop? No one knows. These questions remain among the greatest mysteries in science. For now, they belong to the realm of possibility. Yet even without life, ancient planets are extraordinary. They are cosmic archives, natural time capsules preserving clues about conditions in the early universe. By studying them, astronomers learn how planetary systems formed long ago. They reveal which processes remain constant and which change over billions of years. They help us understand not only distant worlds, but also our own origins. Because every planet tells part of the same story. The story of gravity shaping dust into worlds. The story of stars creating the elements needed for life. The story of a universe slowly becoming more complex with each passing age. Perhaps somewhere tonight, one of these ancient planets is quietly circling its star. Its mountains illuminated by pale starlight, its deserts untouched, its oceans hidden beneath ice, its skies unchanged for billions of years. No one is there to watch. No cities shine in the darkness. No voices echo across the landscape. Only the slow turning of a world older than Earth, older than the sun, older than almost everything we know. And somehow there is something comforting about that. The universe often feels vast and uncertain, yet these ancient planets remind us that some things endure. Worlds can survive unimaginable spans of time. Stars can shine for billions of years. Galaxies can slowly evolve across cosmic ages. And through it all, the universe continues its patient journey forward. As you listen tonight, perhaps imagine one of these ancient worlds, drifting beneath a sky filled with unfamiliar constellations. A planet born in the youth of the galaxy. A world that has watched nearly all of cosmic history unfold. Still orbiting, still enduring, still carrying its silent story through the darkness. And somewhere in that immense age, across billions of years and countless stars, its quiet journey continues. Far beyond crowded star systems lie worlds drifting through the calmest and most silent regions of the Milky Way. Tonight, we leave behind the busy neighborhoods of the galaxy. We move beyond bright clusters of stars, beyond glowing nebulae where new suns are born, beyond crowded regions where gravity constantly pulls and tugs at planets and stars alike. Instead, we travel toward places that few people ever imagine. The quiet places. The lonely outskirts of the Milky Way. The regions where darkness stretches farther, where stars grow sparse, and where entire worlds may spend billions of years in peaceful isolation. When we picture our galaxy, we often imagine a brilliant spiral filled with countless stars. And that image is true. The Milky Way contains hundreds of billions of stars, scattered across a vast disk that stretches more than 100,000 light-years from end to end. But those stars are not distributed evenly. Some regions are crowded beyond imagination. Others are astonishingly empty. If you could travel toward the outer edges of the galaxy, far from the bright central bulge and the bustling spiral arms, the night sky would slowly begin to change. Stars would become less common. The brilliant bands of starlight would fade. Distances between neighboring suns would grow larger and larger. The galaxy would begin to feel less like a city and more like an endless wilderness. Somewhere within these quiet regions, planets may orbit their stars in extraordinary peace. Imagine standing on such a world. The sky above you would be different from the sky we know on Earth. Our night sky is filled with stars because we live within one of the Milky Way's spiral arms. From our perspective, countless distant suns fill the darkness. But on a planet located near the outer edges of the galaxy, the view could be far more sparse. The star-filled river of the Milky Way might appear thinner, dimmer, more distant. The galaxy itself might resemble a faint glowing arc stretching across the heavens, rather than the brilliant band we see from Earth. And yet there would be a certain beauty in that emptiness, a sense of space, a sense of stillness, a feeling that the universe has slowed down. Astronomers sometimes describe these outer galactic regions as relatively quiet environments. Stars there experience fewer close encounters with neighboring stars. Massive stellar explosions may occur less frequently nearby. Gravitational disturbances become rarer. For planets, this can be important. The universe is not always a peaceful place. Stars occasionally pass near one another. Supernovae erupt. Radiation floods surrounding regions. Giant molecular clouds shift and evolve. Over vast periods of time, these events can influence planetary systems. But in the calmer outskirts of the galaxy, such disruptions may happen less often. A planet orbiting a stable star in one of these remote regions could enjoy extraordinary long-term stability. Its orbit may remain nearly unchanged for billions of years. Its climate may evolve slowly. Its star may shine quietly through age after age. And time, perhaps the most valuable resource in the universe, would be abundant. This idea fascinates scientists. Life, if it emerges, often requires long periods of stability. Complex ecosystems do not appear overnight. Evolution moves gradually. Tiny changes accumulate over millions and billions of years. The quieter a planetary environment remains, the more opportunity there may be for life to adapt, diversify, and flourish. Of course, we do not yet know whether life exists in these distant galactic suburbs. But if it does, it may have experienced a very different history than life on Earth. Imagine a civilization developing beneath one of these quiet skies. Its people might grow up seeing fewer stars overhead. Their mythology could be different. Their astronomy might begin with a darker sky. Their understanding of the universe might emerge from a place of solitude rather than abundance. Perhaps they would wonder whether the galaxy is mostly empty. Perhaps they would spend centuries searching for neighboring stars hidden in the distance. Or perhaps they would cherish the darkness itself, because darkness is not always something to fear. Sometimes darkness creates clarity. In our own lives, the quietest moments often reveal the most. The same may be true for worlds scattered through the galaxy's silent outskirts. Far from crowded stellar neighborhoods, these planets may experience night skies of breathtaking simplicity. No nearby suns blazing overhead, no brilliant clusters dominating the horizon. Just distant stars suspended in endless darkness. And yet even these remote worlds are connected to the larger story of the Milky Way. Every star, no matter how isolated, still orbits the galactic center. Every planet still follows gravity's ancient rules. Every atom still shares a common origin with the rest of the cosmos. Isolation does not mean separation. It simply means distance. A quiet world at the edge of the galaxy remains part of the same cosmic family as Earth. The same elements flow through its rocks. The same physics governs its oceans and atmosphere. The same starlight illuminates its landscape. In that sense, even the loneliest planets are not truly alone. They belong to something vast, something beautiful, something ancient. there is another reason these distant regions capture the imagination. They remind us how enormous the galaxy truly is. Sometimes we think of the Milky Way as a collection of stars packed closely together, but the reality is astonishingly spacious. Even in relatively crowded regions, stars are separated by immense distances. In the outer galaxy, those distances become even greater. A traveler moving between neighboring systems might spend centuries crossing the darkness. Entire lifetimes could pass between one star and the next. Yet gravity patiently holds everything together. The galaxy turns slowly. Stars continue their long journeys around the center. Planets continue circling their suns. The quiet never ends. As we drift farther outward in our imagination, the Milky Way itself begins to transform. The bright central regions shrink into the distance. The familiar constellations disappear. The galaxy becomes a glowing island suspended within an even greater ocean of darkness. Beyond it lie other galaxies, countless others, each containing their own stars, their own planets, their own possibilities. From a world in the far outskirts, the vastness of the universe might feel especially profound. The darkness between galaxies would appear larger, the emptiness deeper, the silence more complete. And perhaps that silence would inspire reflection. Because silence, whether in the universe or within ourselves, is rarely empty. It is often filled with hidden meaning. The quiet places between the stars are not barren voids. They are places where time unfolds gently, where worlds may endure undisturbed for billions of years, where ancient planets continue their endless orbits beneath skies untouched by chaos. And tonight, as your thoughts drift through the galaxy, imagine one of those distant worlds. A small planet circling a quiet star. No crowded star fields, no nearby supernovae, no celestial drama. Only a steady orbit beneath a peaceful sky. A world surrounded by darkness, but not loneliness. A world resting in one of the calmest corners of the Milky Way. Still turning, still waiting, still carrying its silent story through the vast and beautiful quiet between the stars. Imagine a night sky where curtains of glowing light never disappear, dancing endlessly across the heavens. On Earth, auroras are among the rarest and most beautiful sights nature can offer. They appear unexpectedly, sometimes for a few hours, sometimes for a single night. Green ribbons shimmer across the northern horizon. Purple arcs ripple above snowy landscapes. Red veils drift silently through the darkness before fading once again into the night. For most people, auroras are fleeting visitors, a brief performance of light, a temporary gift from the sun. But somewhere in the galaxy, there may be worlds where auroras never leave. Worlds where the sky glows every night. Worlds where rivers of light flow endlessly overhead. Worlds illuminated by eternal auroras. Tonight, let your imagination travel to one of these extraordinary places. Picture yourself standing on an alien landscape beneath a dark sky. The horizon is quiet, the air is still, the stars shine above, and then you notice something remarkable. The sky itself is alive, not with clouds, not with moonlight, but with immense glowing curtains stretching from horizon to horizon. They ripple slowly through the darkness, green, blue, violet, silver, sometimes changing shape so gradually that minutes pass before you realize they have moved at all. And unlike Earth's auroras, they never disappear. Night after night, year after year, century after century, the celestial display continues. To understand how such a world might exist, we first need to understand how auroras form here on Earth. Our planet is protected by a magnetic field generated deep within its molten core. This invisible magnetic shield stretches far into space. When charged particles streaming from the sun collide with Earth's magnetic field, many are redirected toward the polar regions. There, they interact with atoms high in the atmosphere. The result is light. A vast natural display painted across the sky by energy itself. The colors depend on the atmospheric gases involved. Oxygen often produces green and red light. Nitrogen can create blue and purple hues. Together they form the breathtaking auroras that have fascinated humanity for thousands of years. But Earth's auroras are relatively modest compared to what may exist elsewhere. Some exoplanets orbit stars that are far more active than our Sun, especially small red dwarf stars. These stars can release enormous amounts of charged particles and magnetic energy. Their stellar winds may be far stronger than anything Earth experiences. If a nearby planet possesses a powerful magnetic field of its own, the interaction could create auroras on a scale almost impossible to imagine. Instead of appearing only near the poles, the glowing lights might extend across entire hemispheres. They could dominate the sky every night, perhaps even every day. Imagine a planet orbiting close to a red dwarf star. The star itself appears larger in the sky than our Sun does from Earth. Its light glows deep orange or ruby red. The planet rotates slowly. Its magnetic field is immense. Streams of charged particles constantly flow outward from the star and crash into the planet's magnetic shield. The result is a permanent auroral storm, an endless ballet of light. No special event is required. No solar storm must arrive. The spectacle simply continues without interruption. Generation after generation would grow up beneath glowing skies. For them, auroras would not be rare. They would be normal. Imagine what that might feel like. Children on such a world might never experience a completely dark night. Ancient civilizations could build myths around the luminous rivers above. Poets might compare them to celestial oceans flowing across the heavens. Artists might spend entire lifetimes trying to capture their shifting beauty. Religions could emerge around the eternal lights. Entire cultures shaped by skies that never stop moving. And perhaps after enough generations, people would stop seeing them as extraordinary at all. The most astonishing wonders often become ordinary when they surround us every day. Yet even then, the lights would remain. Silent, patient, beautiful. There are other possibilities as well. Some giant planets may possess magnetic fields far stronger than Earth's. In our own solar system, Jupiter produces auroras so powerful that they dwarf ours. Its magnetic field captures enormous amounts of charged particles. The resulting auroras glow continuously near its poles. If similar worlds exist elsewhere, their skies may host auroral displays visible from space itself. Imagine approaching such a planet from orbit. Below you stretches a sea of clouds. Above those clouds dance gigantic, glowing rings. Immense circles of emerald and violet light encircling the poles, thousands of miles across, bright enough to illuminate the atmosphere below, visible even from neighboring moons, a permanent beacon in the darkness of space. Some scientists believe that auroras may even help us detect distant planets. These glowing phenomena emit radio signals as well as visible light. Future telescopes may be able to identify exoplanets by observing the signatures of their magnetic fields and auroral activity. In a sense, these worlds may announce their presence through light, a silent cosmic greeting sent across the vastness of the galaxy. What makes auroras especially beautiful is their unpredictability. They are never entirely still. Even on a planet where they never end, they would continue changing. New shapes would emerge, colors would shift, patterns would drift across the sky. Every night would offer something slightly different, no two moments exactly alike. The sky would become a living canvas, a work of art constantly repainting itself. And perhaps that is what makes the idea so comforting. A world illuminated not by harsh artificial lights, not by noise, not by constant activity, but by slow-moving waves of color, gentle light, endless motion. Imagine lying beside a quiet alien ocean. The surface reflects the glowing sky above. Green ribbons shimmer across the water. Purple arcs stretch toward the horizon. Blue curtains drift silently overhead. The stars remain visible beyond them, peeking through gaps in the luminous display. The entire landscape glows softly. No sudden movements, no rushing winds. Only light, flowing endlessly through the darkness. If life exists on such a world, it may have adapted to these conditions in remarkable ways. Plants might respond to the shifting colors. Creatures could navigate using auroral patterns. Nighttime ecosystems might depend on the faint illumination provided by the sky. The lights themselves could become part of the rhythm of life, a permanent environmental feature as familiar as daylight is on Earth. And yet, despite all the scientific explanations, auroras never lose their sense of wonder. Even when we understand how they form, they still feel magical, Perhaps because they remind us that the universe is not merely made of matter. It is made of motion, of energy, of invisible forces shaping visible beauty. Magnetic fields, charged particles, starlight, gravity, all working together to create something unexpectedly beautiful. As we continue our quiet journey tonight, imagine one final scene. A distant planet orbiting beneath the glow of a quiet red star. The landscape rests in darkness. Mountains stand silent beneath the night. Oceans sleep beneath calm waves. And above it all, endless curtains of light drift through the heavens. They have been dancing for millions of years. They may continue for millions more. No audience is required. No observer is necessary. The universe performs the show regardless. And somewhere beneath those eternal auroras, a world continues turning. Bathed in color, wrapped in silence, illuminated by one of the most beautiful possibilities the cosmos can offer. If you're enjoying this relaxing voyage, don't forget to save this video so you can return whenever you need a peaceful escape into space. For now, simply let the lights continue their slow celestial dance as your thoughts drift peacefully among the stars. On some distant planets, simply taking a step could feel completely unfamiliar as gravity reshapes every movement. Tonight we travel to worlds where one of the most fundamental forces in the universe quietly changes everything. Gravity. It is always with us. We rarely think about it. Every step you take, every breath you draw, every object resting on a table, every ocean wave rising and falling beneath the moon. Gravity is there, constant, reliable, invisible. On Earth, gravity feels so normal that we hardly notice it at all. Our muscles developed under its pull, our bones adapted to its strength. Our brains learned its rules before we could even walk. Everything about our daily lives assumes that gravity behaves exactly as it does here. But elsewhere in the galaxy, things may feel very different. Imagine stepping onto a distant planet for the very first time. The ground beneath your feet looks familiar enough. There are mountains in the distance. Clouds drift overhead. A gentle wind moves across the landscape. Yet the moment you take your first step, something feels strange. Not wrong, just different. The force pulling you downward is no longer the same, and suddenly every movement becomes a new experience. Some planets possess far stronger gravity than Earth. These worlds are often larger, denser, or both. Their immense mass creates a stronger gravitational pull, holding everything closer to the surface. On such a planet, your body would immediately notice the difference. Your arms would feel heavier, your legs would work harder. Even standing still might require more effort. A simple walk could feel like carrying a heavy backpack every moment of your life. Jumping would become difficult. Running would be exhausting. The air itself might feel denser as gravity compresses the atmosphere closer to the surface. Rain could fall faster. Mountains might appear broader and lower because gravity limits how tall they can grow. Rivers would flow with a different rhythm. Clouds would form differently. Even trees, if they existed, might evolve shorter and sturdier shapes. Gravity quietly influences everything. Now imagine the opposite. A world where gravity is weaker than Earth's. A place where each step sends you floating slightly farther than expected. Walking might resemble a series of gentle hops. You could leap over large boulders with ease. Objects would feel lighter in your hands. A small stone tossed into the air might take several seconds to return to the ground. Imagine standing on a cliff overlooking an alien landscape. You bend your knees, push gently upward, and suddenly you find yourself soaring far higher than any jump possible on Earth. For a brief moment, it might feel as though you are flying. The moon offers us a small glimpse of this experience. Its gravity is only about 1/6 that of Earth. Astronauts visiting the lunar surface moved with a distinctive bouncing motion. Each step carried them farther than expected. Every movement became slow and graceful. But many exoplanets could offer even stranger environments. Some may possess gravity only a fraction of Earth's. Others may exceed it several times over. Life evolving under such conditions would likely look very different from life here. On a low-gravity world, organisms might grow taller. Branches could stretch higher. Creatures might develop long limbs designed for gliding or leaping. Flying animals, if they existed, could become enormous. The weaker pull of gravity would allow structures too fragile to survive on Earth. Entire ecosystems might appear delicate and elegant. Forests could resemble living cathedrals. Plants might rise hundreds of feet into the air. Meanwhile, on high-gravity worlds, life might take another path entirely. Creatures could evolve compact bodies, strong muscles, reinforced skeletons, wide stances close to the ground. Everything would need to resist the constant downward force. Trees might be short and thick. Animals might appear powerful and dense. Movement could become slower but more deliberate. The entire world shaped by gravity's invisible hand. Gravity influences not only living things, but also weather itself. On Earth, clouds drift through our atmosphere according to familiar patterns. Rain falls at predictable speeds. Storms follow recognizable behavior. But change gravity and the atmosphere changes too. A stronger gravitational pull may create a thicker atmosphere compressed near the surface. Cloud layers could form differently. Wind patterns might shift. Weather systems could become larger or more stable. On low-gravity worlds, the atmosphere might extend much higher into the sky. Clouds could drift at incredible altitudes. Sunsets might last longer. The sky itself could appear different. Everything connected. Everything influenced by the same invisible force. Even the oceans respond to gravity. Waves, tides, currents all depend upon gravitational interactions. On some distant worlds, coastlines may experience tides far greater than anything seen on Earth, especially if the planet orbits close to a large moon. Massive walls of water could slowly advance and retreat across the landscape. Elsewhere, weaker gravitational interactions might create calmer seas, quiet oceans stretching unbroken toward the horizon. Gravity also shapes the planets themselves. The larger a world becomes, the more its own weight presses inward. Deep beneath the surface, immense pressures build. Rock behaves differently. Mantles flow. Cores compress. Some massive exoplanets may contain interior pressures so extreme that materials behave in ways unfamiliar to us. Atoms squeezed together. Minerals transformed into exotic forms. Entire planetary interiors reshaped by gravity's relentless force. Yet despite all its power, gravity works with remarkable patience. It never rushes. It never demands attention. It simply acts, moment after moment, year after year, billion after billion years. Stars form because gravity gathers gas together. Planets emerge because gravity pulls dust into larger and larger bodies. Galaxies maintain their shape because gravity binds countless stars into vast, rotating systems. In many ways, gravity is the architect of the universe. Without it, there would be no planets, no oceans, no mountains, no life. Perhaps that is what makes these distant worlds so fascinating. By changing gravity even slightly, nature creates entirely new possibilities. The same physical laws produce different landscapes. Different skies, different experiences, different stories. Imagine standing on a rocky hill beneath an alien sunset. Perhaps gravity is stronger there. You feel firmly connected to the ground. The horizon seems solid and permanent. Or perhaps gravity is weaker. Each movement feels effortless. The world seems lighter somehow, the sky larger. The distance between yourself and the stars a little smaller. Either way, the experience would remind you that Earth is only one version of what a world can be. One possibility among countless others scattered throughout the galaxy. And somewhere tonight, while you rest comfortably beneath Earth's familiar gravity, countless distant planets continue turning through space. Some heavy, some light, some crushingly dense, some surprisingly gentle. Each shaped by gravity in its own unique way. Each offering a different answer to the question of how a world can feel. As our journey continues, allow yourself to imagine those distant landscapes. Mountains rising beneath unfamiliar skies, oceans responding to unfamiliar tides, creatures moving with unfamiliar grace. Entire worlds dancing to slightly different rules, all guided by the same force that keeps your feet on the ground tonight. The same force that holds planets in orbit. the same force that binds galaxies together. Gravity. Silent, invisible, patient. The quiet sculptor of worlds, endlessly shaping the universe, one gentle pull at a time. Among billions of worlds scattered across our galaxy, there may be one planet quietly waiting to be discovered, a world remarkably like our own. Somewhere out there, beyond the stars visible from your window tonight, a distant planet may be circling its sun beneath familiar skies. Perhaps clouds drift across blue oceans. Perhaps rain falls softly onto continents shaped by rivers and time. Perhaps somewhere on that world, another creature looks upward and wonders whether it is alone. For as long as humans have looked toward the heavens, we have asked a simple question. Are we unique? Or is Earth only one example among countless living worlds scattered throughout the universe? For most of human history, we had no way to know. The stars appeared as distant points of light, beautiful, mysterious, untouchable. We could imagine planets around them, but imagination was all we had. Then, in the last few decades, something extraordinary happened. We began finding them. At first, only a handful, then dozens, then hundreds, then thousands. Today, we know that planets are not rare exceptions. They are everywhere. Nearly every star we see likely hosts worlds of its own. Some stars may possess entire families of planets, rocky worlds, gas giants, frozen wanderers, ocean planets, lava planets, worlds stranger than anything science fiction ever imagined. And among all those discoveries, one goal remains at the center of our search: finding another Earth. Not necessarily an exact twin, not a perfect copy, but a world where conditions might allow liquid water, stable climates, and perhaps life itself. A place where biology could take root. A place where oceans might shimmer beneath distant sunlight. A place where evolution might be writing its own story. When astronomers search for Earth-like planets, they often begin with something called the habitable zone. This is the region around a star where temperatures may allow liquid water to exist on a planet's surface. Too close to the star and water boils away. Too far and it freezes solid. But somewhere in between lies a narrow region where conditions may be just right. Earth happens to orbit within this zone around our sun, and many newly discovered exoplanets appear to occupy similar positions around their own stars. Yet finding a planet in the habitable zone is only the beginning. A world can sit at exactly the right distance and still be completely inhospitable. Its atmosphere might be toxic, its gravity might be crushing. Its surface could be covered by endless deserts or frozen ice. Habitability depends on many factors working together: atmosphere, magnetic fields, geology, climate, stellar activity, even luck. And yet, despite these challenges, astronomers continue finding increasingly promising candidates. Some are slightly larger than Earth. Others orbit quiet stars that shine steadily for billions of years. A few appear to receive nearly the same amount of energy from their stars as Earth receives from the sun. These discoveries inspire a special kind of wonder. Not certainty, not proof, but possibility. Imagine standing on one of these distant worlds. The sky above you might look different. Perhaps the sun is smaller and redder. Perhaps sunsets last longer. Perhaps unfamiliar constellations decorate the night. Yet some things could feel surprisingly familiar. Clouds drifting overhead, rain falling onto oceans, waves moving along a shoreline, the quiet rhythm of a living planet. It is remarkable to think that the ingredients for life appear throughout the cosmos. Water is common, carbon is common. The elements that make up your body were forged inside ancient stars and scattered across the galaxy long before Earth formed. The same ingredients exist elsewhere. The same chemistry exists elsewhere. The same laws of physics operate everywhere. If those ingredients combined once to create life here, could they have done so again somewhere else? No one knows, but it no longer feels like an impossible question. Modern telescopes are beginning to examine exoplanet atmospheres in unprecedented detail. When a planet passes in front of its star, tiny amounts of starlight filter through the atmosphere. By studying that light, scientists can identify certain gases: water vapor, carbon dioxide, methane, oxygen. Each gas leaves a unique fingerprint, a subtle signature hidden inside the starlight. These observations are extraordinarily difficult. The signals are tiny, the distances immense. Yet with every improvement in technology, we become better at reading these distant atmospheres. It's almost like listening to whispers from worlds we cannot see directly. And someday, perhaps, one of those whispers will reveal something extraordinary. A combination of gases difficult to explain without life. A chemical imbalance maintained by biological processes. A true biosignature. A sign that somewhere on a planet orbiting another star, something is alive. The discovery would transform humanity forever. For the first time, we would know that life is not unique to Earth, that biology emerged at least twice in the universe. And if it happened twice, perhaps it happened many times. But even if that discovery remains years away, the search itself is changing how we see our place in the cosmos. Every new planet teaches us something. Every observation expands our understanding. Every distant world reminds us that the universe is far richer and more diverse than we once imagined. The search for another Earth is not only a scientific journey, it is also a journey of perspective. As we discover more worlds, our own planet becomes more precious. We begin to recognize how remarkable Earth truly is. Its oceans, its atmosphere, its forests, its fragile balance. Among all the planets we have found so far, Earth remains the only world known to host life. The only world known to have cities, music, stories, dreams, and living oceans filled with countless forms of life. And perhaps that realization is one of the greatest gifts of astronomy. The farther we look outward, the more clearly we see home. Still, the search continues. New telescopes are being built. New missions are being planned. Future observatories may one day photograph Earth-sized planets directly. They may reveal continents, clouds, weather systems, and perhaps even seasonal changes. What seems impossible today may become routine tomorrow. Somewhere among the hundreds of billions of stars in the Milky Way, another Earth may already exist. Perhaps many do. Perhaps entire civilizations are wondering the same things we wonder tonight. Or perhaps the galaxy is quiet and waiting. Either way, the search itself remains one of humanity's most beautiful adventures, a patient effort to answer one of the oldest questions ever asked. As we drift peacefully through the cosmos tonight, imagine a distant blue world orbiting beneath another sun, a world with oceans, clouds, mountains, and skies filled with unfamiliar stars. Maybe no one has ever seen it. Maybe no one has ever heard its name. Yet it turns silently through the darkness, carrying its own story through time. And somewhere far beyond our reach, another Earth may already be waiting to be found. Beneath frozen surfaces and hidden under layers of ice, unseen oceans may have existed peacefully for billions of years. Far from the warmth of stars, beyond the regions where sunlight can easily reach the ground, there may be worlds that appear completely frozen. From a distance, they seem silent, still, unchanging. Their surfaces are covered by endless plains of ice, stretching toward horizons no visitor has ever seen. No rivers flow across their landscapes. No waves crash against their shores. No clouds drift overhead. At first glance, they might seem lifeless, frozen worlds trapped in eternal winter. But appearances can be deceiving. Deep beneath those frozen surfaces, hidden under miles of ancient ice, entire oceans may quietly exist in darkness. Invisible from space, protected from the harshness of the universe above. And perhaps in those hidden waters, something extraordinary may be happening. The idea sounds almost impossible. How can an ocean exist on a world covered by ice? How can liquid water survive so far from the warmth of a star? The answer lies not in sunlight, but in heat generated from within. Many planets and moons contain radioactive elements buried deep inside their interiors. As these elements slowly decay, they release energy. Over millions and billions of years, that energy creates warmth. Not enough to melt the entire surface, but enough to keep water liquid far below the frozen crust. Gravity can contribute as well. On some worlds, tidal forces gently squeeze and stretch the interior. This constant flexing generates additional heat, warming hidden layers deep beneath the surface. The result is a remarkable possibility. A frozen shell above, a vast ocean below. a secret sea hidden from the stars. We already see hints of this phenomenon closer to home. Within our own solar system, moons such as Europa and Enceladus are believed to contain enormous subsurface oceans beneath their icy exteriors. Scientists have observed evidence suggesting that liquid water may exist beneath their frozen crusts. If hidden oceans can survive here, perhaps they are common throughout the galaxy. Imagine standing on the surface of one of these distant worlds. Above you stretches an endless landscape of ice. The sky is dark, the air may be thin or non-existent. Temperatures remain far below freezing. Nothing seems to move. Nothing seems alive. Yet beneath your feet, perhaps 10 miles down or even 50 miles down, an ocean slowly shifts in darkness. Currents flow, water circulates, heat rises from below. An entire hidden world exists where no sunlight has ever reached. If you could somehow descend through the ice, the journey would feel like traveling into another realm. The frozen layers above would gradually give way to warmer temperatures. The pressure would increase. The darkness would deepen. Then, eventually, after passing through miles of ancient ice, you might emerge into open water. An ocean untouched by wind, untouched by weather, untouched by the changing seasons. A sea that has remained hidden for billions of years. Unlike Earth's oceans, these alien waters would know no sunrise, no sunset, no moonlit reflections dancing across the waves. Above them lies only darkness and ice. And yet, life on Earth has taught us something remarkable. Sunlight is not always necessary for living things. Deep within Earth's oceans, entire ecosystems survive around hydrothermal vents. These underwater regions are warmed by geological activity beneath the seafloor. There, strange creatures thrive in complete darkness. They rely not on sunlight, but on chemical energy released from the planet itself. This discovery changed how scientists think about habitability. Perhaps life does not require a warm surface bathed in sunshine. Perhaps it can survive in hidden oceans sealed beneath ice. Perhaps entire ecosystems could exist far from any star. This possibility has transformed the search for life beyond Earth. Instead of looking only at planets with Earth-like surfaces, scientists now consider ocean worlds among the most promising places to search. Some exoplanets may contain oceans deeper than anything found on Earth. Our planet's deepest ocean trenches reach only a tiny fraction of Earth's radius, but some distant worlds may possess global oceans hundreds of miles deep. Imagine water extending downward farther than any mountain is tall. Beneath those immense oceans, pressure becomes extraordinary. Water behaves differently under such conditions. Exotic forms of ice may form at the bottom, creating layers unlike anything found naturally on Earth. In these strange environments, the boundary between ocean and geology becomes blurred. Water, ice, rock, pressure, heat, all interacting in ways that challenge our imagination. Some ocean worlds may have existed for unimaginable spans of time. Earth's oceans constantly change. Continents move, climate shifts, species appear and disappear. But beneath thick protective ice shells, alien oceans may remain stable for billions of years, sheltered from asteroid impacts, protected from harmful radiation, shielded from violent changes occurring on the surface. If life ever emerged there, it might have had vast stretches of time to evolve. Millions of years, hundreds of millions, even billions. The thought is both calming and astonishing. While civilizations rise and fall, while stars move through the galaxy, while entire planetary systems evolve, these hidden oceans may continue their slow and silent existence. Their waters flowing through darkness, their mysteries untouched, their stories waiting patiently beneath the ice. There is something deeply peaceful about imagining such places. No storms, no rushing winds, no changing skies. Only water moving gently through endless night. A quiet world concealed beneath frozen horizons. Perhaps somewhere in those dark oceans, tiny organisms drift through warm currents. Perhaps strange ecosystems gather around underwater vents. Or perhaps the waters remain empty and silent. We do not know. That uncertainty is part of the wonder. Every hidden ocean represents a question the universe has not yet answered, a possibility waiting beneath layers of ice, a chapter of cosmic history still unread. Future telescopes may help us identify some of these ocean worlds. Future spacecraft may explore icy moons closer to home. One day, humanity may drill through alien ice and sample waters that have never seen sunlight. The discoveries could reshape our understanding of life itself. Until then, these oceans remain hidden, quiet, patient, dreaming beneath frozen surfaces. As we continue our journey through the cosmos tonight, imagine one of these distant worlds, a frozen sphere drifting through darkness, its icy crust shining faintly beneath a distant sun. Nothing appears to move, nothing appears alive. Yet far below, beneath countless layers of ancient ice, an ocean slowly breathes. Currents circle through black water, heat rises from unseen depths, and in the silent darkness of an alien sea, a hidden world continues its journey through time. Unseen, undisturbed, waiting. Every star you see tonight may have its own family of worlds, each with landscapes, histories, and mysteries we have yet to imagine. As darkness settles around you and the universe stretches silently beyond sight, it is worth remembering something extraordinary. The night sky is not empty. Every point of light above you is a sun. Every sun may have planets, and every planet may hold a story. For most of human history, stars appeared distant and unreachable, tiny sparks scattered across an immense black ocean. They seemed simple from afar, beautiful, certainly, but silent. Only recently have we begun to understand how much may be hidden behind those distant lights. A single star may host an entire system of worlds, rocky planets circling close to the warmth of their sun, gas giants drifting through colder regions, frozen moons, ocean worlds, desert landscapes, cloud-covered horizons, places we have never seen and may never visit. Yet they exist, turning quietly through the darkness, living out stories that began long before humanity appeared on Earth. When we discover a new exoplanet, we often learn only a few details: its size, its mass, its orbit, its temperature, perhaps a hint about its atmosphere. But behind those numbers lies an entire world, a real place shaped by gravity, time, chemistry, and chance. A place with mountains we have never climbed, skies we have never watched, seasons we have never experienced. Imagine standing on a planet orbiting a distant red dwarf star. The sky above glows with a soft crimson light. The sun appears larger than ours. Clouds drift slowly across an unfamiliar horizon. For billions of years, that world has existed without anyone knowing it was there. Its days have passed unnoticed, its history unwitnessed, its story untold. Or imagine another world orbiting two suns. Morning begins beneath twin dawns. Two shadows stretch across the ground. As one star sets, another remains. The landscape glows with colors no human eye has ever truly seen. Somewhere in the galaxy, such places may be completely ordinary. To us, they seem almost magical. The universe is filled with possibilities because nature is endlessly creative. Throughout our journey tonight, we have visited worlds of ice and fire, planets wandering alone between the stars, hidden oceans buried beneath frozen crusts, ancient planets older than Earth, worlds illuminated by eternal auroras, storm-covered giants, silent ocean worlds, places where gravity feels different, places where time itself seems to move differently. And yet, these examples represent only a tiny fraction of what may exist. The Milky Way contains hundreds of billions of stars. Many of those stars possess planets. Some stars may host entire systems unlike anything we have imagined. There are almost certainly worlds stranger than the most imaginative science fiction. Worlds where unfamiliar chemistry creates landscapes beyond our understanding. Worlds where sunlight shines through atmospheres of colors unknown to Earth. Worlds where seasons last centuries. Worlds where oceans stretch deeper than mountains are tall. And perhaps worlds where life has followed paths completely different from our own. Every discovery, teaches us humility. Again and again, the universe has surprised us. We expected solar systems like our own. Instead, we found hot Jupiters orbiting impossibly close to their stars. We expected stable planetary arrangements. Instead, we found chaotic systems shaped by migration and gravitational upheaval. We expected a handful of planets. Instead, we discovered a galaxy overflowing with them. Each answer revealed new questions. Each discovery opened new mysteries. And perhaps that is the most beautiful part of science. The journey never truly ends. There is always another horizon waiting beyond the one we have already reached. Another mystery waiting beyond the last answer. Another world hidden within the darkness. When you look up at the stars, it can be easy to feel small. The universe is vast beyond comprehension. Distances stretch across trillions upon trillions of miles. Galaxies drift through endless space. Stars are born, stars die. Planets form and vanish. Everything seems so much larger than us. Yet there is another way to view it. The atoms inside your body were forged in ancient stars. The oxygen you breathe was created by stellar furnaces long before Earth existed. The iron in your blood once traveled through the cosmos as part of exploding suns. In a very real sense, you are connected to the universe you are observing. You are not separate from the cosmos. You are one small part of its ongoing story. The same laws that shaped distant exoplanets shaped Earth. The same gravity that guides alien worlds guides our own planet around the sun. The same chemistry that built mountains on Earth may have built mountains elsewhere. Across unimaginable distances, there is a quiet connection linking everything together. Perhaps that is why we are drawn to the stars, not because they are distant, but because somehow they are familiar. The search for other worlds is also a search for understanding. Every planet we discover helps us better understand our own. Every strange atmosphere teaches us more about Earth's atmosphere. Every alien landscape teaches us something about geology, climate, and evolution. By exploring the galaxy, we learn more about home. And as our technology improves, our view of the cosmos continues to expand. Future telescopes will reveal new worlds. New missions will study distant atmospheres. New discoveries will challenge old assumptions. The next generation may see things that seem impossible today. Perhaps they will detect unmistakable signs of life. Perhaps they will directly image Earth-like planets. Perhaps they will uncover stories hidden for billions of years. The galaxy still holds countless secrets. Most of its stories remain unread. Most of its worlds remain unseen. Most of its mysteries remain hidden within the dark. And yet, little by little, we continue exploring, listening, observing, wondering. That quiet curiosity is one of humanity's greatest gifts. It carried us from caves to observatories, from ancient stargazing to space telescopes, from wondering whether planets existed around other stars to discovering thousands of them. And the journey is only beginning. Tonight, as you rest beneath Earth's familiar sky, countless worlds continue their silent journeys. Some circle red dwarfs, some orbit giant stars, some drift alone between the stars. Some may be covered by oceans, others by ice, others by deserts stretching beyond imagination. All of them continue turning through the darkness, whether we see them or not. Each one carrying its own history, its own future, its own untold story. And perhaps somewhere among those countless worlds, another civilization is looking upward tonight as well. Perhaps they are asking the same questions. Perhaps they are wondering whether they are alone. Or perhaps the galaxy remains quiet, waiting patiently for new discoveries. Either possibility fills the universe with wonder. Thank you for traveling across the galaxy tonight. As you drift toward sleep, remember that somewhere among the countless stars, new worlds are still turning quietly in the dark, waiting to be discovered. The stars will remain. The planets will keep turning. The galaxy will continue telling its stories. And whenever you are ready, there will always be another journey waiting among the stars. Good night.